or Java 9, or Java 11, but Java 8 and up. That's a lot of you. All right. I'm going to tell you I'm going to start with a little story, because every time I do this kind of talk and I use this picture, people ask me, why the hell do you put a motorcyclist trying to drive a motorcycle like that on the front page? Well, let me tell you just a little story. I mean, I have a little cousin, and my cousin is about 3 years old, and every time I give him a new toy, he wants to do everything with this toy. He wants to eat with it, sleep with it, go to bed with it, throw with it, pick it up again, does everything with it. And what we see is that the same behavior as my little cousin, we developers have. I mean, if we have a shiny new toy, a shiny new tool, a shiny new framework, a shiny new way of solving things, we want to solve every single problem with that. And it turns out that that's not always the way that tool or framework is supposed to be used. Just like this motorcyclist. I mean, you can drive a motorcycle from A to B that way. But it's not particularly the way a motorcycle was designed, right? Who drives a motorcycle? Ever drove a motorcycle? A few of you. I'm still asking myself, how does this guy shift gears? I mean, normally you shift gear with your foot. So we can only run in first gear. It will be like, which can be cool. But it's not the way it's supposed to work, right? Same holds with tools and frameworks. I mean, it's like that saying, if you have a hammer, everything looks like a nail. You can solve problems with that tool, but it doesn't mean it actually is the good way to do it. And probably you work with a product manager or a product owner, and you can convince him and you can say, well, hey, it works, right? And if it looks stupid but it works, it is still stupid. Really? Come on. I mean, you may convince your product manager or your product owner because maybe he's not that technical, but I bet you are working with people inside a team. And I tend to work with people that are smart. So saying things like, trust me, I'm an engineer, may work for your product manager or your product owner, but I bet that your coworkers do disagree with that. That's why we're here. But first of all, let me introduce myself. My name is Brian. I'm a developer advocate for a company called Sneak. We actually focus on security, basically, but that's not what we're here for. I'm co-lead of the Utrecht Jug back in the Netherlands. I am from the Netherlands. I work there, I work remotely, and I'm an Oracle groundbreaker. So, I will guide you through a certain amount of statements in this session to help you get a better grasp of functional programming. Some of these things will be like, yeah, duh, I know that. That's only a good thing. And I hope everybody will leave this room with, yeah, that's what we do, or we don't do that, that's good. Then you're on the right path. If there's one or two things that you can take from this, like, okay, maybe I can improve this, it's straight away like that. If all the things you do and I say don't do it, and you do that, maybe you should look at the book again and start from page 1. So first thing, don't do too much in a single lambda. Well, you can take too many people on a train, but what about lambdas? So what is a lambda? Well, this is, I just copy-pasted from an encyclopedia, and a lambda expression basically is something that you can use as functionality as an argument to a method, or the other way around. You can construct a function out of a method. So instead of using data properly, we can insert or create behavior with a function. The so-called higher order functions. But what does that mean in Java? Well, in Java we can see a lambda simply as an anonymous inner function. Basically the same way. Not 100%, but basically. It satisfies the functional interface, and there are basically two ways to write it. One is the input, a function arrow, and the output, the single line lambda, and you've got the input, the function arrow, and the function body. Bringing this to an example, then you come to this. In red, you will see my pretty naive, stupid higher order function. It's a function, or it's a method that takes a function as an argument. It does nothing, just apply the function and do a side effect. But for the sake of argument, this is a higher order function. We give that part of behavior over here with a lambda. And this is a single line lambda. Input something, and then in one line I described what it does, right? It will take the name, it puts something behind it, and cool. If you do this in line, which is what a lambda is supposed to be doing, then this is the way to go. Like your single line lambda. But that's not the only way how you can write a lambda, right? I just told you you could do a function body. Can you imagine if you want to do this thing in line like this and write a lambda like this? Doing if, else, true, false, try, catch statements inside and trying to move that inside your function call and your method call as an argument? Who thinks that makes your code more readable than what you used to do? I personally think it makes your code less readable. And to solve this, you have to think with yourself. If I want to do more in a single line lambda, do I do enough separation of concerns? And for the sake of argument, say you do. Say you need to do something more than a single thing in a single line lambda. We have something that has been in Java for, well, since 1995, and it's called a method. By simply extracting it to a method, like this, and giving it a proper name, because that's the thing we're good at, right? Naming things. And calling it in your higher order function with a method reference, this makes another layer of abstraction and make sure that your code is readable. And not if you do this inline over there, then your code will be less readable, and I pity the guy or girl who has to debug your code. This one was an easy one, right? Let's go to a more debatable one. Returning a stream. Well, it's important to know what a stream is. First of all, a stream is not a data structure. And second most important is, a stream is not a data structure. So, Brian, cool, you're telling me what a stream is not, but what is a stream? Well, actually, it's a fuzzy thing. A flow of data that's derived from, for instance, a collection. And with a stream, you can create these awesome pipelines. But what's the most important part? It's an intermediate result. It's your draft document, not the final one you send to your boss, but you're still working on something. Do you want your boss to judge already if it's still in work in progress? Probably not. And lazy evaluation by nature. Okay. Going to that stream, we basically have two different kind of functions, intermediate functions and terminal functions. Maybe you already know, but the intermediate function gives you back a stream, which keeps the lazy evaluation alive, and the terminal function reduces the stream to something that is actually useful. Say a number, a list, a set, an array, whatever. It reduces it back to something you can use. The problem with a stream is that if I do this, first of all, I bound my stream to a variable, which is a bad thing, because you can only use a stream once. And if I bound it to a variable, you probably will use it twice, 3 times, 4 times, and you will get in trouble. Because using it once over here is no problem, but using it the second time will give you an illegal state exception, because you can only consume a stream once. Okay, having that in your mind is cool. But what about returning a stream? How can you be sure that a stream that you take from, say, for instance, another library isn't already consumed? You simply don't. Because you cannot check on it. You cannot say stream.is already used or something. There's no such thing. So, returning a stream, then you have to be pretty sure, you have to be extremely sure that your stream is not already consumed. So, I won't say never return a stream, but just be careful, because returning a stream is good if it's your private intermediate function. You want to do some thing on that stream and you want to give it stream back and preserve that lazy evaluation, perfect. Keep going, but then you thought about it. If you create a new stream every single time. List.stream creates a new stream every single time. Perfect. It may be considerable to use a stream or return a stream if the result you are giving back doesn't fit into memory. A list of 1 billion items probably exceeds your memory, or you must have a big wallet with a lot of money and a lot of cloud space. But most of the time it doesn't fit in your heap, or maybe even your result set is infinite. Then a stream can be useful because of the lazy evaluation. But by default, and teach your juniors this please, don't return a stream if not necessary. By default, take a collection because everybody knows how to work with collections. It's a stateful thing. You can work around it, you can loop over it, no problem. You can create a new stream out of it. You've got all the tools in the world to handle this. And you are sure that it's not already consumed. If you have to go outside of these boundaries, then use a stream, not the other way around. Who likes mutable objects? Nobody. Who likes immutable objects? And the rest is still sleeping. Good morning. Well, let's go into some description of functional programming. I copied this from Wikipedia, an encyclopedia. Let's keep it to that. Let's not go into politics. But the most important part of functional programming are these bold words. It uses functions, avoids changing state and mutable data. It works with this is declarative programming paradigm, and it works with expressions instead of statements. Well, think about it. If I quote my favorite scientist, which is Mr. or Dr. Albert Einstein, he says, insanity is doing the same thing over and over again and expecting different results. Well, he probably did not work with mutable objects. Right? Come on, if you have a mutable object and you can change the state while asking something, which most people do, it will turn up in something different totally. You have no clue if I have an object, I created it, I put it into a function, and I change it in the meantime, then something else comes out. So you have no prediction of how your model is. So actually, doing the same things over and over again on the same object can end in different results, which basically is insane. Well, let's look at it from another point of view. If I ask you a question, what is your favorite color? And you say blue. And I ask you 2 seconds from now, what's your favorite color? If you say red, you've probably been drinking. But most of the time you will say blue, right? Because that's the state you are. And if we keep all our objects like that and just ask questions on it and do not change the state, then it would be much easier to argue about your code and to debug your code, right? Because if it does change state, then I have to keep some sort of mental mind map in my head. Okay, if I do this, then it will be in that state. Do it again, then it will be in a completely different state. That's hard. It's probably not hard to program it, but it's hard to read it afterwards. And you do not write code for machines. You write code for people. Because you probably are the most perfect programmer in the world. Not. You probably make mistakes. And that means that somebody else has to read your code. And to make it better for them to read or less effort for them to read, that's your goal as a programmer. So don't write code for machines, write code for your co-workers and for the people that have to maintain and to expand your code base. Doing that with immutable objects would be much easier. I don't say it's easier to create, but it's easier to handle afterwards. So asking a question, what I did with the color just now, should not change the answer, right? If I ask you a question, that doesn't change the other, nor should asking it twice. So immutable objects gives you less moving parts. It's easier to reason about and you don't need to keep that mental mind map in your head. Well, there's this thing with streams. They say streams cannot mutate. Let's go into code because that's much more fun. Is this, let me just turn my, alright. So, what I have here is a list of beers. No, I'm not an alcoholic. I just like beers. Say for instance, I have my beer list over here and I want to map a certain function on it. Say, I want to change the name of it. They say that you cannot do this. So, and let's okay, cool. That doesn't work, it says. Right? Because, well, you cannot mutate. But what is the problem we see here? Let me just make this a tiny little bit bigger for you. The problem over here says no instance of type variable R exists so that void conforms to R. Well, I can fix that. If I go into my beer, and I have this setter over here, which is void, I can secretly, nobody sees this, right? Hey, and now I can. Printing the new list, printing the old list, let's see what it does. And you see that both the new list and the old list contain a new name. So it is possible to mutate within a stream. But please don't do it. I just give you a whole example why not. But what should you do? The best thing you could do if you want to mutate inside is or don't use a stream. Use a for loop or something, because these things still exist and you still can use them. But if you want to do it within a stream and keep that lazy evaluation, maybe you should do something like this. And then I go to my beer, and instead of a setter, I rename it to with, because that's a better name in my opinion. I do not return this, but I just return a new beer with the name and the original alcohol percentage. If I run my code now, what you see, if it wants to run, please run. Yes, it runs. Now you see that the new list contains new objects and new names, and the old one stays the same. If you take this to a broader perspective, then you do not have to care about your input anymore, because it stays the same. Please make sure that if you want to use mutation in a stream, or you want to mutate your objects, and just create new ones. Yes, it increases your heap, but it's the trade-off to be far more readable and far more knowledgeable and make sure that you can argue about code instead of just changing it, because you don't know what it does. If you change it here, maybe it changes there as well, and you might get into trouble. Getting back to the next one. So, we talked about mutate. Please do not return a new copy. Let's go to the for each, because people love this expressional way of programming. Like, yeah, it's functional programming. What I earlier stated is a form of, it does use expressions instead of other things. And what you have to know about a for each statement is that if you use it on a stream, it's a terminal function. So that means it's the reduce part of the MapReduce algorithm. It takes a consumer and it can apply side effects.
Changes. Smoothie. Making smoothie.
Calendar.
No meetings today. Remember, and twist at 9:30.
Fire off.
Fire off.
Open door.
Door open. We're gonna do one more.
Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open. Open door.
Repeat that.
Open door.
I didn't understand that.
Hey! Open door!
Hey, on the floor.
Open door! Open door! Open door!
Error.
I like a good after party though, but after my talk, please. For the people who did this, for the people who solved this, thank you. So, getting back to that for each part, right? What you can do with a for each is applying side effects on a stream. One side effect is printing. That one is easy. I have a list of strings and I can print them. Printing is considered a side effect. What I can do as well is set that same thing that as what I tried to do before, right? Setting in this case an alcohol percentage. But what I see in a lot of things is that people say like, okay, that stream part you do, that is lazy, right? So I can do it again, right? Because it's lazy. And there's where things go wrong. I actually saw this kind of code in a batch process. What people tried to do over here was, we have an object, and we want to enrich that same object with sources from outside. Say database A with ratings, and database B with, in this case, reviews. We want to create that, we want to expand that object with these third-party sources, put it in, and then apply it back into the database for my, in this case, mobile app. Which is a good thought. But by doing this, so doing the for each statement twice, then you do a terminal function twice, which basically means that the for each statement is nothing more than syntactic sugar for a for loop. So if I rewrite this to an old-fashioned for loop, you will see that you do two for loops over the same freaking list. Nobody would do that because they say, okay, if you please go over that list once and enrich that product. So don't make the mistake that because streams are lazy, the for each statement is lazy as well. That's not. That's a terminal function, and that makes sure that your list is evaluated from top to bottom. And in this case, again, if you want to mutate your object, which I do not recommend, of course, please do it in an old-fashioned for loop. Why not? It's not that hard. We've done this for years. If you want to do this in a stream, create a new object. These are the basic two things. Not doing it this way. So stating that a for each loop, for each statement would be lazy is wrong. Order of operations. This one is a fun one. And I need you with this. Say I have beers, and every beer has a brewer, and every brewer is from a country. Say I want the first 3 unique brewers' countries from my beer library and print it out as a comma-separated value. Is this okay? Who thinks this is correct? Who thinks this is wrong? One. Who has no clue what I'm talking about? Who is just like, yeah, get over it, give me the answer? The rest of it, okay. It's wrong, because these two, you distinct over the beer, or over the brewers, and then you limit 3. I don't know how it is in Turkey, but I know for sure that you have more than one brewery in Turkey, right? So you do not have the first 3 brewers' countries. In this case, what you have to do is put it over there. So instead of getting it to the brewer, you have to distinct on the countries. Okay, that can be solved because we're all good programmers. We write, who doesn't write unit tests? See, everybody writes unit tests, so you find out that this is just a matter of running your test and you find out that well, somebody made an error. Let me get into another example. Let me get into this example. What we see over here is we have an in-stream iterator. I distinct over it and I limit over it to make sure that my possibly infinite in-stream will finish. And then I do a for each printout. Pretty logical, seems okay, until I run it. If I run it, you'll see that it gives me a 0 and a 1, and then it's stuck. And if I go to my terminal and I blow it up, you will see that it's still running. But why? Well, that's because the order of operations is not okay. What it does over here, it gives you a stream of 0, 1. 0, 1, you get the point. Then a distinct. 0. Oh, there's an O. 0, 1. And then it waits. But the limit in the meantime says, okay, my first item is a 0. My second item is a 1. My third item, because I have to limit to 10, and it's waiting. Can you imagine what will be done if I do this in parallel and run it again? It doesn't even give me an answer, but it does run. You see? So, who here works in the cloud? Who has a cloud account or what works? If you do this in the cloud, then it will probably, well, you will not get your bonus this year. It will not be a denial of service, it will be denial of pocket money, I guess. Anyway, let's finish this one because it's getting warm in here. My fans are spinning up. What you have to do here is make sure that the order of operations is okay. If I limit first, like this, and distinct afterwards, then I will have 10 items over here, and distinct in this case to only 2. And then you have more than 2 items, of course, in after the first stream. But then you are certain that it will finish. People asked me last time, why didn't the parallel thing give me an intermediate result? Because parallel uses the fork joint thread pool. If you do not specify an own thread pool, it uses the common fork joint thread pool, but it uses a fork joint thread pool. And it forks the part that can be done in parallel, so the stream part, and it joins again at the terminal function, the for each part in this case. So, because it cannot join, it's still stuck in that parallel stuff, it will not give you a printout because only at the end it will join again and give you the printout. So with a parallel function, you're even worse. You even have worse problems. So first case, don't use parallel just because you can. If you use parallel everywhere, it basically occupies all the threads in your common joint thread pool, and use of parallel will shrink by the time you instance it for something you really need. The other thing is, that first you have to look closely at the order of operations. Meaning that if you work with lazy evaluation, it doesn't mean that the order of operation just, whatever. Don't use an infinite stream. If you do not need to use an infinite stream, please do not use an infinite stream. Because why should you? Normally you traverse over a list, or over a set, or you just have to do something like 10 times or 12 times. Why not use a range or a range close to do so? And if you want to do an iteration over an int stream, please use the one that's provided from Java 9 and on, that gives you a predicate where you can insert a predicate that you are sure that it will actually terminate. Because infinite streams can be very useful, but if it doesn't finish, then it can be very useful for your cloud provider. Creating higher order functions. Who creates their own higher order functions? 1. Fegmats. A higher order function. Instead of taking it as a parameter, you can also, taking that as a parameter just in the Stream API, you can also create these things yourself. Because now you can not only insert data, you can insert behavior. And that means you can create another level of abstraction and make your separation of concerns even better than it was. Basically what we want to do is reduce boilerplate. Say, okay, this is a very simple example. Say I have a log to upper function which does, say, 100 lines in my super interesting code before the red line and 200 lines after that thing. Then you probably say your method is way too long. That's true. But if I want to do a log lower, what we typically saw the last couple of years or the last decade is that people simply copy, paste it, and change that one line with functionality. Okay, but copy-pasting doesn't give you errors, right? No. Who thinks that copy-pasting code is a very good way to run your code base? Everybody, cool. Do it, keep doing it. Actually, what you want to do is just abstract that one line. You want to insert behavior. By doing it over here with a lambda, I can insert only that part of behavior and I have the rest of my super interesting code. I just declare it once. I do not have to copy paste it. If it's changed, I can change it in one place and I'm good to go. Okay, Brian, this is fun, but this is a super boring example. Did you ever use this in real life? Yes. I had a real life situation in my former job. I worked for a web shop, big web shop, like the equivalent of Amazon, but back in the Netherlands. And what we did, we had a MongoDB cluster. That MongoDB cluster consisted of one primary and a few secondary nodes. And if we needed to write, what we stored in that were the shopping baskets. So you wanted an item, you put it in your shopping basket, and if you want to pay, you pay your shopping basket. Perfectly reasonable. By storing these shopping baskets over there, if you need to write to that point, you want to do that, you have to do that on the primary node, because the secondary node will read only. But you do not want to read from the secondary node and write to the primary, because that can be different. So you want to read from the primary and write to the primary if you actually need to change something. Basically what we needed to do was read from the primary, do an added statement, run the rule engine, because there were a certain amount of rules on that, and then save back to the primary. And if you see what the problem is, we have to do that for add an item, delete an item, recreate an item, alter an item. So you see now I already have 4 functions, and we had a dozen of them. And the only thing that's different from either of these functions is the edit part. Ooh, red wasn't a good choice. But it's the edit part. How did we solve that? With our own higher order function. What we did is we created a mutator by ID, which simply has the basket ID and a consumer action. And that consumer action basically was our abstraction. Reading from the primary was done one time, running the rule engine was declared one time, and saving to the primary was declared one time. So simply add item was calling my mutator by ID and giving it the right consumer in this case. By doing this, my code base shrunk, and I only, if I had to do something on, for instance, this of course is shrunk already, but if I needed to do one thing more, for instance, after the rule engine, I could do it in the mutator and do not have to do it in the add, remove, or whatever. This way we created a new level of abstraction and made our code more readable and reasonable. Optionals. Who likes optionals? Cool. Because if you look at optionals, well, it says it's Java's implementation of the maybe monad. Yeah, whatever. What it does, it encapsulates the thing that you can have a probable null. And we want to give your user the point that, hey, maybe you should look into it before using it. Well, this is the problem with optional. We live in an object-oriented world, and you can assign an optional to null. If we just promise each other that we will not ever do that, we do not have a problem anymore. Yeah? So don't do this. Then you want to get an optional. That's cool and stuff, but if I do it like this, you probably end up with a no such element exception. So what people do is this. Hey, let's check with an if statement if it's present or not, and then get it. How is that any better than just checking a null? It's not. You're doing the same thing. But what you should do is using the if present or the map function on it. If you do it that way, the map function only kicks in if an optional is present. The if present consumer will only kick off when it is present. That's cool, but what else? If I want to do something else, what then? Say we have 3 alternatives. Or else get, and or else throw. Well, the or else throw is quite simple. If the optional is empty, then it throws an exception. Fine. But what if I want to do something else? Say I have two functions over here. The run if exists and the run if empty. And you see this upper function, it's an optional, and I map the run if exists, and that kicks off because, well, it's filled with something. So my end result will be that it prints out foo. That's what I think. If we look at what it does print out, I hope you can all see it. It prints out only run if optional is filled, but also the only run if optional is empty. And that's weird, because an if-else statement, we probably think it will be short-circuited, which it's not. And that's because you're using the or else. Or else is not meant to insert behavior. If you do that, for instance, on your database when checking for a user, and if it's not there, let's create a new one, you end up with a mess. What you should do is use the or else get and give it a consumer. Because the consumer will only be evaluated when needed. And this one is actually meant to insert behavior, and the or else is only meant to give you a default value. And if you do that by running a method, then you have to be very careful. Running it now will have the desired outcome. So, if using or else, please make sure that what's inside your or else is doesn't have any side effects. If you need to do new stuff in it, alternative flow, then use the or else get. Alright, let's skip that one. Let's go to some code for the last time. And we are going to exceptions. Because normally it is not possible to use exceptions or a function that throws an exception inside a stream, right? That's one of the hardest parts you need to cover. If I have my do function over here that throws an exception and that needs to be checked randomly, it throws an exception randomly. So doing something like this doesn't work because it says, well, you need to do try and catch. Doing so, okay, maybe I just throw new runtime. This will work, but it's ugly, right? What we can do is the following. We can, if we want to do this, say the try and catch, because you need to do a specific thing when that exception is there, then you have to catch it. But if you just want to wrap it in a runtime, what we can do is first of all, create your own checked exception functional interface. From that point, I will create a util file. Yes, this is the best name I could make up. No, I want to not and I will make a function called public. Oh yeah, it's generic, so I have to put a tr in here as well. Wrap with JSON checked function and does something. Let's import that function. So what it does, it needs to return a normal function. And I apply it to t. I do the try and catching over here. I simply throw new runtime, exception over here, and what I can do over here in my exception handler is simply wrap it. Yeah, I need to import it statically, but it doesn't work it right now. So I can wrap it over here. So my stream stays readable. But the problem with this is, if you have a stream and it hits an exception, what does it do to your stream? It kills your stream instantly. And that's not what I want. If my stream is killed instantly, and say my stream was an infinite amount, or say 100 million of baskets, from that previous example, and at say 200,000 it kills, because for instance I have a an exception, an IO exception. Is that what I want? That I have to start over again? Probably not. What we can do, if we want to say that my exceptional situation and my good situation, if I want to treat them both as data, and afterwards say, okay, this one went wrong, that one went wrong, that one went wrong, okay, I handle it afterwards, but I want to traverse from top to bottom, then I have to introduce something new, which is called the either type. The either type basically is a type that can either be a left or a right, or a left and a right. So it can, and it's a wrapper type, and it means that the left can be something and the right can be something. So it can be an int or a string, not both. It can be a string or an object, or it can be an exception and an object. And that one is nice, because say it goes wrong and I wrap it into an either type, and I wrap it into the left one, then I have an either left and then the exception wrapped in it. Or I have an either right with the good solution. Having that, and I wrote this, you saw the try-catch example I wrote. If I lift it into an either type and say if it goes well, I make it a right, and if it goes wrong, I make it a left. What I do over here, and I wrap it into my either, and run it now, then you see whatever, oh yeah, no exceptions. Then you see what happens now. Normally, if I just try catch it and it ends up in a runtime exception, it will already finish after the first one. But now it ends to the last one. So I will see that my first one went wrong, my second one went okay, and my third one went okay. And at the end I can say, wait, maybe I just filter out the wrong ones, throw them away, do nothing, and keep the right ones. Cool. But I'm in charge, not my exception kind of thingy. The only problem with this is that I have the exception, and my exception is not very useful. Because the either type can handle everything, we can also put the original value in the left side, or the exception and the original value in the left side, which makes it far more convenient for me to do, for instance, a retry. Going to my either type again, and I will publish the code, of course. I also wrote a lift with value, and instead of just inserting the exception over here, I insert both the exception and the original value, which gives me the power to do everything I want again. I can retry, I can throw it away, I can just get the normal ones, whatever I want. So going to my exception and lift with value, if I do it like this and run it over here, then you see then if something's wrong, I see that I have both my exception and my original value. Does any one of you ever work with Scala? Ever worked with, for instance, a library called Vermeer or Java slang? In Scala, Bob, and in Java slang or Vermeer, there is this try principle, which does the same thing. Only try can, just like my first example, handle the exception. And if you want more than the exception, then you have to fall back into the either type. I want to end with the last thing is like, yes. So we have this try that has a failure and a success, which basically is the first example of my either type. A try is just a more specific one, but I will not go into that much. Take a look at a library called Vermeer. If you do functional programming, it has a lot of awesome stuff in it. If you only want to handle exceptions this way, you can write it yourself in 10 lines of code. I will publish the code for you so you can take a peek at it. It was a lot in 45 minutes. And I want to end with the statement that this is me. This is my Twitter handle. If you have any questions afterwards, please come up to me. This is the new thing I'm running, the Secure Developer. Take a look at it. It's more security-wise. All codes and all slides will be published, and I was asked to look at this thing. You said don't usually use parallel streams simply because you can. Which are proper scenarios to use a parallel stream? Only use a parallel stream if you actually need the computation power. Because most of the time people use parallel stream just because they can and they think that it's faster. But because your fork joint thread pool is just a certain amount of threads, it will be filled up. And then again, you use parallel and it will get slower than just a normal stream. So what I want to say is don't just use a parallel stream because you can. Use it only when you need that computation power and you need that computation power fast. If there's no way to do so, or if it's not necessary, don't do it. I don't know who was the initial questioner. I hope this answered your question. The second one, what is your favorite refactor plugin to avoid mistakes in Eclipse for Java? Intellij. I only use Intellij. I grew up with it. I actually used Eclipse before, switched to Intellij and got hooked on it, but it's a personal decision. I know that some coworkers of mine nowadays use VS Code actually, which is a proper one. So I think it is personal. Refactoring I mostly do in Intellij. I love it because I know almost all the shortcuts, except for demoing, then everything goes wrong, of course. So
That seems to be all.
yeah.
Thank you, Brian. Thank you very much.
All right, thank you for coming. If you have questions, come up to me, Twitter to me, and I will post everything on my Twitter handle that you saw before.